We ready for this one? Could somebody, can somebody point, so I've got two, this is the last thing we'll look at here. I've got two parallelograms. I'm going to color code them. Well, actually, there's a letter on there, so let's just go with, let's go with that. So that's area 1. Let's call it area 2. So let's call that trapezoid 1 and trapezoid 2. Could somebody point out where the bases of trapezoid 1 and 2 are? Where are their bases? Could somebody point that out on the screen? Nathaniel, let's see. Ah, nice. So for trapezoid, let's start with trapezoid 2. There's a base, and there's another base. For trapezoid 1, there's its same base, and there's its same base. Okay. For some reason, we're used to seeing them this way. Okay. There's our whole parallelogram. The area of that parallelogram is made up of its base times its height, and height works out to be on. It seems to be almost that line would be its height, not quite. So it doesn't quite meet. It doesn't quite meet at a 90 degree angle there. So that'd be close to its height. For this one, its area would equal its base times height. Okay. Again, the area of that parallelogram is base 1 and base 2 times its height, and then we just want half of it. Okay, there we are. No applause this time?
Yay!
Okay, I'm going to go through the same steps I just went through. I've got a whole parallelogram. If I've successfully divided it exactly in half, the measurement should be the same. So 6 centimeters, and the other trapezoid has a 6 centimeter base. This trapezoid over here has another base that's 8.5 centimeters. This one has a base that's 8.5 centimeters. Okay? So let's label those bases so that we can use them in our formula. Red and red. Let's label that as base 1. That's also base 1. We've got base 2, and there's also base 2. Okay, let's find the area of our whole parallelogram. Right, to find the area of our whole parallelogram, it's base times height. The area of our parallelogram, that's not great. The area of our parallelogram is that entire base times its height. And that entire base is made up of base 1 and base 2. I need to add them together before I multiply by the height. I don't want just one of them multiplied by the height when I follow order of operations. That'll give me the area of the whole parallelogram. I divide it in half because I only want one of those trapezoids. Thank you. Thank you. Yeah. Okay. This example. So here's an example where it's been cut up. Okay? The triangle's been taken out. I'll just highlight a couple things here. You can see it, it's been cut very well to fit exactly in place. That triangle came from over here. Okay, so it was cut off that side and moved over to turn the parallelogram into a rectangle that has the exact same area as the parallelogram did. Okay? And to find the area of a rectangle, we multiply its base times its height. Okay. Let's go back to the one we were working on just a minute ago. Which one? Okay, so this part of the trapezoid, I can label it as the base of the trapezoid. What about this part right here? What would I label that? Zach? The base as well. Now, do we see the confusion there? So we have to differentiate between the two of them. Okay, they can't both be called the same thing. And if you're shouting out base 1 and base 2, I'm pretty sure you did some research and found a formula that identifies them as that, because that is the convention. That's what we call them, is base 1 and base 2. Okay, so we'll call that base 1. We'll call that base 2, and it really doesn't matter which one we choose as base 1 and which one we choose as base 2. Okay. I'm going to use a shortcut for it. I'm going to use the letter B with a subscript. That's a letter down at the bottom, or a number down at the bottom. And for this one, I'll do the same thing, base 1 and base 2. Okay. What is this length right here? What's that length? You can call it out. Base 2. That's exactly the same as base 2. Let's mark that up with some of the symbols we know. So that is the same length as that. Okay. What's this called at the top?
Base 1.
Base 1. Okay. We also know that base 1 is parallel to base 2. Okay. What shape was this whole thing? The whole thing's a parallelogram, right? And we know how to find the area of a parallelogram. Okay, so to find the area of this entire parallelogram, we know that already, right? So we just spent some time decomposing shapes and using a decomposition to find the area. We're going to do the same thing right now. How have we decomposed this parallelogram? Into two congruent trapezoids. So we know how to find the area of a parallelogram. It's base times height. But we don't want the whole parallelogram. We just want a trapezoid. What are we going to do once we found the area of the parallelogram? I don't see many hands up yet, so let me just try and get some people caught up with us. If we find the area of the whole parallelogram, we don't want that. We just want the area of this part of it. What are we going to do with the area of the whole parallelogram? There we go.
Divided by 2.
Makes sense? Because we only want half of it. Okay. How do we find the area of the parallelogram again? You can call it out.
Base times height. Base times height.
Okay. What's the base of our parallelogram? What's the base of our parallelogram? Let me choose another color. Somebody said a color. Somebody called it a color. What's the base of our parallelogram? Yellow? Wait a second. No, it's not.
Yellow, red.
That's not the base of our parallelogram. Yellow and red. That's the base of our parallelogram. Yellow and red. How do I show yellow and red? Like, how do I explain yellow and red? I had other labels for them. I didn't just label them with colors. What else did I label them with? Base 1 and base 2. So here's where it gets exciting. Area equals base 1 and base 2. So I want to put them together. I want to put those two together before I multiply them by the height. Okay? And that'll give me the area of the whole thing. What do I do with that once I've got it? If I only want the area of the green shaded trapezoid, divide by 2. And there we are. We now have an area formula to use to find the area of a trapezoid. Okay, we need to try that again.